In part 3 of this lesson, where we convert between mass and the number of molecules, we'll be answering question 3. Question 3 is interesting. It's different than questions 1 and 2, where they ask us for the number of molecules. This time they give us the number of molecules and they want us to find the mass. The question reads, what is the mass of a drop of water containing 3.55 times 10 to the power of 2 H2O molecules? H2O being water, obviously. So we have the number of molecules and it's defined by this number. We can convert these molecules using Avogadro's number into the number of moles, and here's how. What I can do is take Avogadro's number and customize it to what I want. Instead of atoms, I'll write down molecules. And notice that Avogadro's number is technically a rate. We have molecules at the top and moles at the bottom. And with every conversion factor or with any rate, you can flip it where you have number of moles at the top and molecules at the bottom. And if I do that, if I flip it as 1 mole over 6.022 times 10 to the power of 23 molecules, and multiply it to the amount of molecules that they tell us, which is 3.55 times 10 to the power of 22, like this, I'll end up with the amount of moles. And from that, I can find out, using the formula mass of water, how many grams there are. And grams represents the mass. So let's go one step at a time. Let's start by multiplying this with that, which is 3.55 times 10 to the power of 22. Next, I'll take this number and divide it by bracket 6.022 times 10 to the power of 23. Close the bracket. And this gives me 0.05895. 0.05895 moles. This has 3 significant figures, and the amount of significant figures here don't count because it's considered an exact number. So our final answer should also have 3, although I won't round now, but I will put a dot underneath this 9 to signify that the 9 is the last significant figure. So I have the number of moles. Now I will find the formula mass of H2O. H2O, we have a molar mass of H being 1.008 AMU, and I'll multiply that by 2 because of this subscript, and the molar mass of oxygen is 16.00, and you can find this in any periodic table, and we won't be multiplying that by anything because it's considered 1. Once again, I'll use my calculator. I have 1.008 times 2 plus 16.00, giving us 18.016. 18.016. Everything after this one is insignificant because, take a look at our calculation, we had 3 numbers after the decimal place here and only 2 numbers in the decimal place here. So when it comes to adding, we consider the lowest amount of numbers after the decimal place, and so this number should only have 2. Now that I have the number of grams per mole and I have the number of moles, I can multiply these two numbers, because by multiplying 18.016 with the following, the number of moles will cancel out, giving us the amount of grams in this drop of water. So let's go ahead and do that. We have 18.016 grams per every 1 mole times 0.05895 moles. The moles cancel out. Now it's a simple calculation. 18.016 times 0.05895, and we end up with 1.0620 grams. 1.0620 grams. We have 4 significant figures here, and here we have, or should have, 3, so our final answer should also have 3. Everything after this 6 is insignificant. 1.06 grams in this drop of water that contains this many H2O molecules. And there you have it. That is how to convert between mass and the number of molecules.